Well, my name is Miguel Badovinac, and I'm going to talk about two iron-based mortars blended with a pozzolanic additive and different admixtures, a mineralogical, textural, and physical mechanical study. Well, the addition of inorganic and organic substance to artificial materials such as mortars and bricks is an ancient practice in the field of construction in order to improve its manageability, strength, and hardening. The additions are essential components in masonry materials. The additives can be pozzolans, mineral fillers, and ceramic powder. For this project, three types of mixtures have been considered, which are like aggregate, that is the perlita, water retention agent, that is cellulose derivative, and plasticizer, that is polycarboxylate. Materials and methods. All mortars were prepared with hydrated dry calcitic lime and calcareous aggregate. The pozzolan used is metakaolin. 8 mixtures with different proportions were prepared. The mortars were stored for 7 days and standardized steel molds. Aptitude: mineralogical phase, texture, resistance to flexion and compression. To studies of mineralogical phase, two techniques were used: thermogravimetry and X-ray diffraction. Chemical composition. In this table, we can observe percentage of oxides, calcified lime, calcareous aggregate, and metakaolin. Mineralogical phase. In this table, we can observe name of the mortars, the eight mortars, the sand binder ratio, percentage of metakaolin, and whether or not it has the presence of the perlite, the cellulose, and the polycarboxylate derivative, and the percentage of water. Mortar's texture. Well, in general, the core of the mortars appears more porous than the surface, and this is because the carbonation comes from the outside to the inside of the mortar. And finally, the mechanical properties that were obtained. Here's shown the resistance to bending and compression of mortars. As we can see with the naked mortars that are mixed with perlite and other mixtures have much higher values than mortar that only have lime and aggregate. We can also see that the last mortar has a much lower resistance value. In this is because it has too high an aggregate content, and this results in a mortar with a poor cohesion between the grains and consequently has less mechanical resistance. To finish, we can conclude that it was observed that the pozzolans led to the formation of hydrated phases, while the perlite, the cellulose derivative, and the plasticizer do not produce any mineralogical and morphological change in mortars. It also concludes that the addition of 20% metakaolin causes an improvement in the resistance. And finally, it concludes that by establishing adequate proportions of additives and pozzolanic additives, it is possible to improve the properties of the mortar without unduly modifying the original characteristics of the all-life mortar.